Okay, so this is Leetcode number 120, which is a triangle. So what is in the given in the question there? We have given a triangular array. Starting from the top element, we must reach the bottom now. It doesn't matter in any of the point on the bottom. Since we have to reach only on the bottom. From each element, we can move on either in the two positions in the next row, either directly down or diagonally right. Okay. So let's say for this example, there's triangle given here. This is actually given in the form of the array here. So like what is the possible path here? If we have to find what is the minimum path sum, so if we have to follow this path, like starting from this 2, then 3, then 5, then 1, so this is the minimal path sum in among the all of the path there. So what is the total sum here? This is 11, so that is our required answer. So this is the same thing we have to done in all over the question. We have to do this. So now come to edit part there. Since at each position we have two choices, either we have to go to down or either we have to go to we have to right say or right down diagonal. Okay, so in the two options there, either you have to go to this just below or just right or down diagonal there. Since the problem asks for the minimum path sum there, so this naturally leads to the recursion decision problem. Why? Because at each of the cell we have to, since two choices, either it comes to it, either it goes to this or either it goes to this. So in that cases we should go for the recursion. So simply we make a recursion tree there, and like first of all I have to define what is the definition of my f there. So this is nothing but the, so what is the f here? So it is the minimum path sum here from row comma column to bottom of triangle. So this is the definition of my, wait a second. Okay, so this is the definition of our recursive function there, and what is our goal here? So we have to find what is the f of 0 comma 0. Okay, so this is our goal there. If you have to start from this, you have to reach to the up like a bottom cell there, and what are the minimum here, we have to return that value. So since we can say one thing there, what is the meaning of going down? So if we have to go down, so what it means, we simply go to the row plus 1 comma column. And what is the meaning of the diagonal? I don't write the complete write down diagonal. You can treat this as, you can already simplified it as by using the simply diagonal there, so that's why I use this. So what it means, this is row plus 1 columns plus 1. Okay, so means there's only the either the down there or either the right below diagonal there. So finally what is our function become here? So it is nothing but the let's say I can use the vector v instead of the using the triangle word here. So this, that is our the, now first of all we takes the value of that current cell there, and now we add on the minimum value, or we have to call the for the minimum path. And how this is going, it is called for the both of the cases there, or it is of the row plus 1 comma column plus 1. Wait a second. Okay, so this is our the definition of the row comma column. Now what is our base case here? We can also write the what are the base case. So base case is nothing but the, whenever we have to reach the last row, let's say we have to release last row there and the column, so we have to simply store that value v of that last row there and simply the column here. Okay, So this is the basic things that we should go we have to think about this question. Now let's say keep dry running in this question. Let's have to take this input. We simply represent this not in the tabular manner because this is easily understandable as it is the given in the question, simply diagonally or in the bottom. So that's why I made this figure in the this direction way. So now we see if I have to start from the f of 0 comma 0, how is our recursive tree is goes on. So first of all it calls for the f of 1 comma 0, f of 1 comma 1 means if you have to start from here, either we can go below down. So this is for the down condition and this is for the diagonal condition. Now again, if for here it is for the down, it is for the diagonal, here it is for the down, it is for the diagonal again, and it is goes on till it doesn't exceed our the base case there. Okay, so like from the 2 we have to explore path through the 3 or over the 4. Now we notice one thing there. If we see one thing here, wait a second, see here this f of 2 comma 1 and this f of 2 comma 1, this repeated again and again. So what it means, this is nothing but the overlapping subproblems. So this is the hint that we can optimize this by using the storing the these values, so that in future their storing values can be used. And what is the what do you mean by the storing? This is nothing but the simply using the dp vector in which we have to store this value. Okay, so this is a whole dry run. Now come to the code part there. So this is the brute code. So this is our main function here. We simply return the sol function and pass our 0 comma 0 since we have to start from here, and this is a v vector. Now this is a definition of our sol function. There's a row, the column there. There's a base case whenever our row is reached to v dot size minus 1, means it reached to last row, we have to return that value only. There's the two option there. We simply return our the current cell value and the minimum, whatever the minimum in this, we have to return that value here. Okay, so this is for this this is the brute force there. I think you might be surprised, we don't exclude any of the or we can handle why we don't handle any of the edge cases when it goes to the exceed our triangle. So if we see carefully, if we have to see in this case there, so we see one thing there, what are the possible movements in which it has to travel. So either it can go is in the down part or either it has to goes in the diagonally part there. So you can see very well, if we are at any of the cell here, it is not possible to doesn't exceed this triangle of the cell. There's the only exit point is whenever it reaches to the exit, it reaches to the end of the row, and now it has the way to goes out of the boundary. But we know one thing, whenever it reaches until it reaches to the end of the row, we simply using this value there. This is that our base case, so we don't allow it goes to. Otherwise, in any of the cases, you can you can think of any about the you can think about any of the cell here. If let's say if we are standing at this cell, so either we can go to 5, either we can go to 7, or let's say if we have to make the bigger triangle here. Now let's say here one element there, here the 2 element there, here the 3 element there. So in any of the element, or we can say if any of the cell there doesn't way possible to go exceeding the boundary of this triangle. So that's why we don't concern about excluding those extra cases there, because it is not possible. Okay, so so I think you should understood what is the how this brute force come there. And now if we have to discuss what its time complexity have. So we see one thing there, since our triangle is it is very symmetrical in nature, it is unlike the grid, it has a different grid or column, so it is not in the our triangle position. So whatever the size for the vertically, similarly it extend horizontally same way. So basically this is n, total number of cells in this triangle is n, and each have 2. So what is the time complexity? So the time complexity for each is equal to this 2 power n there. Okay, and like again we discussed the what is the space complexity is nothing but the of n, that is our recursion, stack there. Like this recursion is goes on, and what is the total length there when it completes the in the how it is compute. So in the worst condition it has to traverse all of the, so that's why we use the O of n as its space complexity. Now since it is exponentially in nature, its time complexity, and it gives a TLE for the constraint given in the question there. So because it is the triangle size is goes to till 200, so in the worst condition when it goes to 2 power 200, so that is the very use, so that gives the TLE. So that's why we should go for the memoized version. So this is the already same, there's nothing new. We use one extra vector here, we have to pass this, and this definition also same. We simply see this part here and simply store all of the value in the DP and simply return that. And so now what is its time complexity? So it is nothing but the time complexity, so it is n of a square. Okay, so and what is its space complexity? It is of a square and plus recursion stack there. Okay, so that is I think you can be understood with this, and we can further optimize this by using tabulation method and space optimize, but at this moment we don't have to concern about that. It is acceptable here. Okay, so thank you.